Hi everyone. Today we're going to be completing our notes on 3.2 graphing using intercepts and end behavior. I want to start off with this review. We're going to evaluate the limit that describes the end behavior. So here we're looking at this first function. We have the limit of negative 3x minus x squared plus 4 over x cubed as x approaches negative infinity. So we're looking at the left-hand end behavior. So we know that for polynomials, this isn't a polynomial because of this last term, but we do know that for polynomials, the end behavior can be determined using the dominant term rule. So we're looking at the term with the highest power. So that first term has a power of 1, the second term has a power of 2, and then that third term has a power of negative 3. So this disqualifies it from being a polynomial due to that negative exponent. But we do know that the highest power here is that power of 2. So we know that the dominant term is negative x squared. We know that this is a quadratic opening downward, so therefore both ends are approaching negative infinity. So then it follows that the left-hand end behavior is negative infinity. For the second problem, here we have the limit of negative the quantity x minus 4 times the quantity x minus 1 squared times the quantity x plus 1 cubed as x approaches infinity. So looking at this, the dominant term here, well, I see we have 1x here, we have 2x's here, and we have 3x's here. So that tells us that our dominant term with that negative out in front is going to be negative x to the sixth. Because we have an even degree dominant term, or an even degree polynomial here with a negative leading coefficient, we know that both ends are approaching negative infinity. So therefore, the right-hand limit as x approaches infinity is negative infinity. All right, so number 2, let's go ahead and connect the sign chart to the graph. All right, so we're going to sketch a graph of this polynomial function, and we're going to find the end behavior, the real roots, and the y-intercept. Okay, so we'll start with the end behavior. I noticed that the dominant term here, so the degree is, we have 1x out front, 2 inside that first grouping, and then 2 inside that second grouping. In that, second grouping, or that third factor. So that tells us that we have a a degree of 1, 2, 3, 4, 5, so a degree 5, and a negative leading coefficient. So that tells me, so leading coefficient is negative. So that tells me that the limit of g of x as x approaches negative infinity is equal to positive infinity. And then the limit of g of x as x approaches positive infinity is equal to negative infinity. So odd degree with a negative leading coefficient. So that tells me that we have roots. Because this is already factored, or at least for the first two factors here, I know that we can find those roots using the zero product property. That third factor here, I notice that this trinomial, this quadratic trinomial, cannot be factored. So in order to find the roots, we have to use the quadratic formula. So let's start with those first two factors. Here we have roots at x equals 0 and x equals 3. And for that last factor, we have the solution to the equation x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll go ahead and write that. Negative b plus or minus the square root b squared minus 4ac all over 2a. Remember, that's the quadratic formula. So plugging it in here, we have negative b. So remember, the coefficient, if written in standard form, the coefficient to the quadratic term is a, the coefficient to the linear term is b, and then that constant term is c. So that tells us that negative b is positive 4, plus or minus the square root of b squared, or negative 4 squared, 16. And then we have minus 4 times 1 times 2. So 4ac, and then all over 2 times 1. Okay, so what we have here is 4 plus or minus the square root of, well, we have this multiplication first. 4 times 1 times 2 is 8. 16 minus 8 is 8. And then over 2. Well, I know that the square root of 8 reduces to 2 root 2. And so then we can divide out that 2 in the denominator. Actually, let's go ahead and write out that step. So 4 plus or minus 2 root 2 all over 2. And then we can divide out that denominator. So we get 2 plus or minus root 2. Okay. So then we have roots at x equals 2 plus root 2, and then I'll go ahead and write out the last one, 2 minus root 2. Okay, so I notice that we have 4 roots despite our degree being 5, and that's because this 0 at x equals 3, or this root at x equals 3, is multiplicity 2. Okay, so let's go ahead and write these. So x is equal to 0 has multiplicity 1. At x equals 3, this is where we have multiplicity 2, because that factor is squared. And then at x equals 2 plus root 2, that has multiplicity 1. And then we have at x equals 2 minus root 2, that has multiplicity 1 as well. Okay, so let's go ahead and draw the sign chart. And real quick, I just want to get an approximation for 2 plus and minus root 2. So over to our calculator, I'm going to hit 2 plus the square root of 2, and I'm going to hit Control Enter to get a decimal approximation. That's about 3.414. And then I also want 2 minus root 2, and I'm going to hit Control Enter. Oops, I didn't put my 2 in there. There we go. Control Enter, and that gives me my decimal approximation as well. Okay, so we'll keep that in mind. We've got a little bit like close to 3.5, and then we've got close to like 1/2. All right, so on our sign chart, here we have 0. We have 1 at 3. Oh, actually, in between, I forgot our 0.5, or 2 minus root 2. And then we have our 3, and then we have our 2 plus root 2. Okay? I know that the end behavior, because we have a negative leading coefficient, left-hand side is approaching infinity, right-hand side is approaching negative infinity. So we can already start with that. About 0, we have multiplicity 1, that's odd, so it's going to flip sign. At 2 minus root 2, we have an odd multiplicity, so that's going to flip the sign as well. At 3, we have multiplicity 2, which is even, so it's going to keep the sign there. And then at 2 plus root 2, we have multiplicity odd, so it flips that sign. All right. Last thing I want to find here is the y-intercept. So I'm just going to create a space for that. So the y-intercept. Remember, the y-intercept is where x equals 0. So what we can do is we can take our function and plug in 0, or evaluate the function for g of 0. So we have negative 0, and then times 0 minus 3, and then squared. And then we have 0 squared minus 4 times 0, and then plus 2. Okay? Now, one thing you might notice here is that we're multiplying everything by 0. So then we have a y-intercept of 0, 0. And that should make sense because we also have an x-intercept of 0, 0, the origin. All right? So I notice that we have our y-intercept, or our x-intercept, 0, 0. We have 3, 0, and then we've got our 0.58, which is 2 minus root 2, and then we also have 3.4, which is right about here. Okay. So a quick sketch of the graph. The y values, it's okay if they're not completely accurate, but we do have to see that end behavior and then what's going on at each of the zeros. So I notice that we are starting from the positive side. So our function is going to come down. It's going to pass through this 0, and then it's going to come back up and pass through the 0 at 2 minus root 2. It's going to come back down, and then it's going to bounce at x equals 3, and then it's going to come back down and end up being negative on the right-hand side. So we should have a function that looks like this. Again, don't worry too much about those y values. This is just a quick sketch of the graph. Okay? The big thing that we're looking for is it passing through or bouncing at each of the zeros? All right. So number 3, a sign chart for polynomial h is shown below. The roots are -1, 3, and 6. The degree of h is 4, right? A possible factorization. I'm not sure what happened with the formatting here, but this is a sign chart. So I'm just going to go ahead and draw that number line in. All right. So I know that the degree is 4, which is even. So I notice that the left and right-hand side are negative. So that tells me that we have a negative leading coefficient. Okay. I also know that we have zeros at -1, 3, and 6. So I'm going to go ahead and write out each of those factors. So x plus 1, we have x minus 3, and then also x minus 6. Now looking at this, I notice that the multiplicity of the 0 at x equals -1 is odd. The multiplicity at 3 is even, and the multiplicity at 6 is odd. And I notice this because it's changing signs about the 0 at -1 and at 6, but it's not changing signs at the 0 at 3. So that tells me that this factor, x minus 3, must be an even multiplicity, or it happens an even number of times in the factorization. Because it's degree 4, if we square it, that accounts for all of our zeros here. So this is a possible factorization. All right, so go ahead and flip the page. Now we're going to get some practice sketching these graphs. So we'll start with f of x in number 1. Here we have a degree 3 polynomial, because there are 3 x's here, 1 in the first grouping and 2 in the second. The roots, or the x-intercepts, we have one at 5, 0, and we have one at -1, 0. Multiplicity of each of the zeros, we have at x equals 5 has multiplicity 1, and at x equals -1, we have multiplicity 2. The y-intercept, if we plug in 0 in for x, we would evaluate f of 0. So this would be equal to negative the quantity 0 minus 5 times the quantity 0 plus 1 squared. And we get negative, and then -5, and then 1 squared. Well, this is equal to positive 5. So then our y-intercept is 0, 5. And then finally, the end behavior, we're looking at an odd degree with a negative leading coefficient. So that tells me that the limit of f of x as x approaches negative infinity is equal to positive infinity. And then the limit of f of x as x approaches positive infinity is equal to negative infinity. Okay. Finally, let's make a sign chart. So we have zeros at 5 and -1. I know that the left-hand side is approaching positive infinity and the right-hand side is approaching negative infinity. At -1, we have an even multiplicity, so the graph stays the same. The sign of the graph stays the same, or the function, I should say. And then at x equals 5, the multiplicity is odd, so the sign changes. And so it flips from positive to negative. Let's go ahead and graph this. So I know that we have a y-intercept of 5. So we can go ahead and plot that. We have an x-intercept of 5. And we also have an x-intercept of -1. All right, so the left-hand side is going to be coming down from infinity. It's going to bounce at -1, come up, hit the y-intercept, and then it's going to go back down to the x-axis. It's going to bounce, come up, hit the y-intercept, and then pass through that 0 at x equals 5. So here's a quick sketch of the graph. Okay, let's try another. Number 2. Graph f of x equals the quantity x plus 3 times the quantity x plus 1 squared times the quantity x minus 2. So the degree, I notice that we have 4 x's here, so degree is 4. X-intercepts, we have one at x equals, actually I'll write it as ordered pairs, like we did before. X-intercepts, we have -3, 0. We have -1, 0. And we have 2, 0. Multiplicity of each of these zeros, so the one at x equals -3 has multiplicity 1. The 0 at x equals -1 has multiplicity 2. And the 0 at x equals 2 has multiplicity 1. The y-intercept, f of 0, so evaluating, we have 0 plus 3 times the quantity 0 plus 1 squared times the quantity 0 minus 2. We're left with 3 times 1 times -2, and that's equal to -6. And then our end behavior, we have an even degree with a positive leading coefficient, so that tells me both ends are approaching infinity. So limit of f of x as x approaches negative infinity is infinity, and the limit of f of x as x approaches positive infinity is infinity as well. So our sign chart, we have zeros at -3, -1, and 2. Both ends are going up to infinity. At -3, the multiplicity is odd, so it changes sign. At -1, the multiplicity is even, so it stays the same. And then at 2, that 0, the multiplicity is odd, 1, so it changes sign. Okay. One thing that I want to point out real quick is that I noticed that the y-intercept is -6. And so I should expect that on my sign chart where the y-intercept would be, that this interval is also negative. Okay. We didn't check for that last one, but I just want to point out that it holds true for this one as well. Our y-intercept was positive. And so if we look at the interval containing x equals 0, or our y-intercept, that interval is also positive. So just a quick check for that. So let's go ahead and graph this. So I notice that we have zeros at -3. 1, 2, 3. We have one at -1. We have a y-intercept of -6. 1, 2, 3, 4, 5, 6 right here. And then we have another at x equals 2. All right. So we know we're coming through the 0 at -3 from positive infinity. It's going to pass through that 0. It's going to come up and it's going to hit -1, and then it's going to bounce. And then it's going to go back down, hit the y-intercept, and then come up, and then pass through our last 0 at x equals 2. All right, so here's another sketch. I always like to check, does this look like a polynomial of degree 4? Yes, it does, where each of the zeros, we should have 4 of them, where one of them is counted twice because of the multiplicity. All right, we got 2 more for today. Number 3, graph f of x here is 2 times the quantity x minus 3 times the quantity x plus 2 squared. The degree, I notice we have 3 x's here, so degree is 3. X-intercepts, we have 3, 0, and we have -2, 0. Multiplicity of each of these zeros, we have at x equals 3 and x equals -2. So at x equals -3, 3, the multiplicity is 1, and at x equals -2, the multiplicity is 2. The y-intercept, so f of 0, is equal to 2 times the quantity 0 minus 3 times the quantity 0 plus 2 squared. And so this is equal to 2 times -3 times 4, which is equal to -24. Okay. And behavior, degree 3 with a positive leading coefficient. That tells me that the limit of f of x as x approaches -infinity is -infinity. And then the limit of f of x as x approaches positive infinity is positive infinity. So a sign chart, we have zeros at, at 3 and -2. I know that this is degree 3 with a positive leading coefficient. So that tells me left end's going down, right end's going up. At x equals -2, we have an even multiplicity. So the graph is, or the function is going to keep the sign about that 0. And then at x equals 3, we have odd multiplicity. So it's going to change sign. And then I also noticed that the y-intercept is negative. So inside that middle interval containing x equals 0, the function should be negative, and it is. All right. So let's go ahead and sketch this graph. We have at -2, a 0, and then we have at 3, another 0, and then we have another one, a y-intercept at -24. So we'll go ahead and graph that. I know that the left-hand side is going to come up to, starting from the negative side, come up to -2 and then bounce. It's going to come back down, hit that y-intercept, and then it's going to finish off by passing through the 0 at x equals 3. All right. We got one more for us today. Now, I noticed that this one here is in standard form. It is not factored. So remember, for any of these, we do have to factor them. This is going to use a technique called factoring by grouping. And so I noticed that if I were to group some of these terms together, then I'm going to be able to factor each of them, factor GCF from each of them. And so I'm going to just factor, or I'm just going to group these, the first 2 terms, as a sum of the next 2 terms as well. All right, so this would be equal to, if I just factor out the GCF from that first grouping, the GCF is x squared. And so what's left over is x plus 3. In the second grouping, if I factor out a -4, then what's remaining is x plus 3. And when factoring by grouping, you should find that what's left over in that grouping should be the same in both of these terms. And so what we get is x squared minus 4 times the quantity x plus 3. Okay? Well, I know that x squared minus 4 is a difference of squares, so this is equal to x plus 2 times the quantity x minus 2, and then we've also got that x plus 3. All right? So that tells me we could look at the factored form, or we could look at the standard form. The degree of this polynomial is 3. The x-intercepts, we have one at negative 2, 0. We have one at positive 2, 0. And we have one at negative 3, 0. The multiplicity of each of these zeros is 1. So add x equals negative 2. The multiplicity is 1. Add x equals 2. The multiplicity is 1. And add x equals negative 3. The multiplicity is 1. For the y-intercept, again, we'll evaluate for f of 0. So this is equal to, actually, you know what? I noticed that we've got it in standard form. So if we plug in 0 for x, we'll see that it's just that constant term. So 0 cubed plus 3 times 0 squared, and then minus 4 times 0, and then all minus 12. Well, all of these terms here with the factors of 0 are going to cancel out. So all that's left is negative 12. That tells me that my y-intercept is 0, negative 12. All right. And behavior. So this is cubic with a positive leading coefficient. So the limit of f of x as x approaches negative infinity is negative infinity. And the limit of f of x as x approaches positive infinity is positive infinity. So a sign chart here. We have zeros at x equals negative 2, negative 3, and 2. So negative 3, negative 2, and 2. Left-hand side is approaching negative infinity. Right-hand side is approaching infinity. I know that at x equals, actually all of these, the sign flips. They're all multiplicity 1. So we're going to go from negative to positive to negative to positive. Okay, I'll do that quick check. Is our y-intercept negative? Yes, that interval containing our y-intercept is negative. So this checks out. All right, so let's go ahead and plot this. So 1, 2, 3. I'm giving myself a little bit of space here. And then we have 1, 2 right here. And we have a y-intercept of negative 12. So that's right here. I know that the left-hand side is coming from negative infinity. It's going to pass through that 0. It's going to come back down, pass through the next 0. It's going to come back down, hit our y-intercept, and then it's going to finish off by passing through that other 0, x equals 2. All right? All right, so this has been our notes on pages 11 through 13. This has been graphing using the intercepts and then also talking about end behavior. Okay, we're going to get a lot of practice on this in class, so we'll see you tomorrow. Goodbye, everybody.